Dr. Jingbo Louise Liu. Today we are going to start your chapter 2 about alkane and cycloalkane. Essentially, we are going to cover almost 22 different topics. So first of all, I want to show you how to classify the hydrocarbons. Generally speaking, you have two types of different hydrocarbons. So one is called aliphatic, another one called aromatic. Among these aliphatic hydrocarbons, so we can also distinguish them into three different main groups. The first one is called alkane, second one called alkene, third one called alkyne. In the alkane, so you are only going to see carbon-carbon single bonds. And in your alkene, you are going to see carbon-carbon double bond or double bonds. And alkyne, you have at least one carbon-carbon triple bonds. For example, the commonly used one, such as ethane, you have C2H6. Second one called isolene, C2H4. Between carbon and carbon, you are going to see a double bond. The last example called acetylene, you have the carbon-carbon triple bond. The formula is C2H2. The second major class of hydrocarbons is called aromatic hydrocarbons. This aromatic hydrocarbons is much more complicated. The simplest one is our commonly used organic solvent called benzene. So aromatic compounds, sometimes also called arenes, they are going to form the cyclic compounds. Normally you have double single carbon bonds alternatively occurred, similar to the conjugations. The second topic we are going to learn is about different models for chemical bondings. In this organic chemistry, we are mainly focusing on the covalent bonding between carbon and carbon, carbon, hydrogen, and carbon, and some other atoms, such as oxygen, nitrogen, such as halogens. So in this case, we are going to show you three different models. The first one, I think you already learned from your general chemistry, called the Louise model. This Louise model normally is going to mention about the electrons going to be shared by the two different atoms. This Louise electron structure is going to be more applicable when you are discussing about formal charge, about 2D structures. And there are two more different chemical bonding models. One is called the valence bonding theory, valence bond theory called VB. Second one called molecular orbital theory. So let's use the hydrogen simple formula H2 hydrogen atoms as an example to show you when the formula is going to be formed, a molecule is going to be formed when different atoms approaching to each other. What's going to happen? Meaning, what's the driving forces for these two atoms to be approaching to each other, and what's the energy changes? So here we can see, due to the electrostatic forces, so two hydrogen atoms approaching to each other, initially your attraction is going to occur, the attraction between the electrons and the nucleus. So that's the driving force for the hydrogen atoms to approach to each other to form a hydrogen bond. At a certain point, normally when hydrogen and hydrogen are closer to each other, you form the covalent bonding. At this point, repulsion is going to be experienced by both hydrogen atoms. The repulsions occur between two nuclei, and repulsion also occur between different atoms.